If I told you there's an easier way to do limits, you'd probably be either upset at me or excited about it. Probably not excited about it, but relieved. And there is, and it's called Lahapital's rule. Not even great at pronouncing it, but that's what it's called. Some people call it the hospital rule because it looks like hospital, right? So the idea is if you run into an indeterminate form, when you try to find the limit and it's an indeterminate form, then we can use Lahapital's rule to find the limit. It's a really easy rule to use. Now, there's a bunch of indeterminate forms, but AP, fortunately, because this is more of a Calc 2 topic, for AP Calc AB, they really just focus on two indeterminate forms, and that's 0 over 0 and infinity over infinity, something we've run into before. And by the way, this test will fail if the limit is able to be found just by substituting in a number. If you substitute a number in and you get 5 over 0, that's not indeterminate. That's going to either infinity or negative infinity. If you end up substituting a number and you get like 5 over 7, that's your answer. So you can't use L'Hopital's. It'll actually fail and give you the wrong answer. But let's say you plug in the number, you get 0 over 0 or infinity over infinity. You could take the derivative of the top and the derivative of the bottom, and then plug in the limit and see what you get, and that will be the new answer. If it works, then great. If it results in another indeterminate form, then you just run through this rule until it finally works. So let's see an example. So let's say you have to find this limit, and it's like, seriously? This looks crazy, right? So if you were to plug in 0, you get 0 minus 0 over 0 plus 0. So 0 over 0, so it's indeterminate. So what we're going to do is we're going to find the derivative of the top. So this is going to equal the limit as x goes to 0, since it was an indeterminate form of 0 over 0. And we're going to find the derivative of the top, which is 7 minus cosine of x over 2x plus 3 sine of 3x. Remember, we had to do the chain rule on that, not sine, it's cosine. So now let's plug in the 0. And remember, cosine of 0 is 1 on the unit circle. So this is going to be 7 minus cosine of 0 is 1 over 2 times 0 is 0 plus 3 times 1, because cosine of 0 is 1. So this ends up being 7 over 3. Now I need to double check something here. Why did I put cosine of 0 as 0? I said cosine of 0 is 1. There we go. What am I thinking? So you get 6 over 3, which is 2. All right, so very good. So that one works out. Use L'Hopital. So it looks like a crazy limit here, but it's not that bad. This one's same idea. If you plug in a 0, e to the 0 is 1. 2 minus 2 is 0 over 0. Doesn't work out. But if we take the derivative of the top and the bottom, this will become 4e to the 2x. Reference derivatives if you forgot how to take a derivative. 2x plus 1. Now if we plug in the 0, we'll get 4e to the 0 over 1, which is 4. And this pattern just keeps going on. Derivative of this one, unfortunately, we got to do the product rule this time. But if you plug in the 1/2, you get square root of e minus square root of e. That doesn't work. And on the top, cosine of pi over 2, because that would be 1/2 pi, is also 0. So let's try the product rule. Let's see what happens here. So f prime, so this equals a limit of x goes to 1/2. And don't get this confused with the quotient rule. That's the biggest mistake I see is people all of a sudden think this is the new quotient rule. This is not the new quotient rule. This is to evaluate limits. So product rule on the top, because we have to take the derivative of the top, is going to be 1 times cosine of pi x plus, thought I was doing quotient rule again. Gotta be careful. I just gave you guys a speech about that. And then it's going to be f times g prime, so times negative sine of pi x times pi. Kind of a difficult derivative there. And then on the bottom, square root of e is just a constant, so the derivative of that's 0. So derivative of e to the x is just e to the x. So let's simplify this a bit before we plug in our numbers. And so when we plug in the 1/2, we'll have cosine of pi over 2, which we already went over is 0, minus pi times 1/2 times sine of pi over 2. And sine of pi over 2, remember on the unit circle, is 1 over e to the 1/2, which is just square root of e. So we'll have 0 minus pi times 1/2 times 1/2 over the square root of e. Oh no, it's not 1/2. Sine of pi over 2. I'm making all kinds of mistakes right now. Is 1, right? Cosine is 0, so this is 1. That makes more sense. So we end up with negative pi over 2 over the square root of e, which is over 1. So you flip and multiply, and you'll see your answer is this one, not this one. Pi's on top. Maybe I should do that multiplication, right? And now you can see it's negative pi over 2 square root of e. Here's another one. I'll leave a detailed